Hey class, Miss Anderson here. We are starting Unit 7. Today we are going to look at just the first part of Unit 7, and we want to know how we find the interior angle sum for shapes with more than 3 sides. We already know that the angles inside a triangle add to 180 degrees, and we are going to use that today to figure out how to find the sum of the interior angles for the other shapes. We're going to be working with polygons today, and remember that the root word poly means many, so polygons are two-dimensional shapes with many straight sides. And then we have a convex polygon and a non-convex polygons. So a polygon that has all interior angles that are less than 180 degrees is called a convex polygon. And convex polygons also have all the vertices point outward. And if you draw a line segment from one of the vertices to the other, it stays inside the shape. So I have a couple pictures over here. The first convex polygon, you might be familiar with that. That is a trapezoid. So you can see that these interior angles here are all less than 180 degrees. And if you were to draw a segment from any one vertice to the other vertice, the segment stays inside the shape. And all the vertices point out. And then you have the non-convex polygon. You can see where this interior angle right here is greater than 180 degrees. So that makes it not convex. Plus, if you go from this vertice to this vertice and connect that, you can see where the line segment is on the outside of the shape. And that vertice down here, that was over 180, points inward. So those are the things that make it convex versus non-convex. So the convex polygons are the ones that we're going to be working with to find the interior sums. Then we're going to learn about regular polygons. So if you see the word regular, that means that all the sides and angles are congruent. So it's a regular polygon if all the sides are the same length and all the angles are the same degree measure. We have the equilateral and equiangular words again. And you might remember those hopefully from our triangle unit. Equilateral means that all the sides are congruent. Equiangular means that all the angles are congruent. And so we use those words again to talk about polygons. Here are the polygons that you may be familiar with. You will be expected to know how many sides each of these shapes have, so it might be worth studying a few of these. I know that you probably remember triangles have 3 sides and 3 angles. Quadrilateral, quad means 4. So those are your squares, your rectangles, your trapezoids. Pentagon is 5 sides. Hexagon is 6, heptagon is 7, and I always get the hexagon and the heptagon confused, so you definitely want to study that. We probably remember that octagon is 8, then nonagon is 9, and decagon is 10. And then anything over 10 we call based off of the number of sides. So let's say that it had 12 sides, then it would be called a 12gon. That would be 12 sides and 12 angles. If I said it was a 20gon, that would be 20 sides and 20 angles. So anything over 10, you just use the number of sides that it has and then add the gon. So polygon interior angle sum, it's based off of the number of triangles that you can make inside the polygons, and I'll show you how that works. The formula is the number of sides minus 2 times 180. So I'll show you where that comes from. So we know that the triangle has 3 sides, so we are going to say the n represents the number of sides that the shape has. And a triangle consists of 1 triangle, and the interior angle sum is 180 degrees. So then quadrilaterals have 4 sides, And if you look at the quadrilateral, and you can connect either the two vertices right here, or you can connect the two vertices right here, and you can see that the quadrilateral has made up of two triangles. And if you think about that carefully, then two triangles at 180 degrees each is going to give you 360 degrees. So for a quadrilateral, it is going to be 360 degrees for all four angles inside that shape. So a pentagon, we're going to connect a couple of our vertices and see how many triangles we can make inside the pentagon. So if we start with just connecting this, we have this triangle right here, and then we could connect it down here as well. We make another triangle, and then our third triangle. So the pentagon is made up of 5 sides, and it consists of 3 triangles. And then 3 triangles at 180 degrees is going to give us 540 degrees. So the interior angle sum formula is you take the number of sides, you subtract 2, because there's always 2 triangles less, or there's always, the number of triangles is always 2 less than the number of sides. And then you take it times 180 degrees, because there's 180 degrees in each triangle. So notice that the number of triangles is always 2 less than the number of sides. Hence where we get the interior angle sum formula from up here. Now I always do it the other way around because you can multiply in any order. So like for example, 6 times 7 and 7 times 6 are the same answer. So you can do 180 times n minus 2 or n minus 2 times 180. And I usually do it the other way around because I like to remember to take the number of sides, minus 2 to get the number of triangles, and then times 180. So, for example, if we want to find the sum of the interior angles in a convex nonagon, we are going to have to remember that a nonagon has 9 sides, which means that there are 7 triangles. So we're going to take 7 times 180. And that's going to give us 1,260 degrees. So there are 1,260 degrees total if you added up all 9 angles, because if there's 9 sides, that means that there's also 9 angles. And the 9 angles are going to add up to 1,260 degrees. So the number of triangles, that's the n minus 2 part. So you're taking this number of sides, minus 2, that means there's 7 triangles inside, and then times 180 degrees for each triangle gives us the total. All right, the next one. We want the measure of each interior angle of a regular convex hexagon. Keywords here is going to be the word regular and hexagon. So hexagon, remember, is 6 sides. Heptagon is 7, so we got to be careful with the 6, 7. Hexagon is going to be 6 sides. Hex and then hep. I'm just going to double check because I always mess it up. 6 sides. Okay. That means that the number of triangles is going to be 2 less than that, which is going to be 4. That's the n minus 2 part. Then times 180 degrees, which means you're going to have, let's see, 400, and then 4 times 80 is 320. So you're going to have 720 degrees total in a hexagon. And then the key word regular means that they are all equal angles and sides. So if we want to know how much each interior angle measures and they're all the same, there's 720 total. So you're going to take that divided by 6 and you're going to get, let's see, 72 divided by 6 is 12. So 120 degrees for each angle. So regular means they're all the same. Hexagon, 6 sides. So you find the total, divide it by 6. Good to go. All right, the sum of the measure of the interior angles of a convex polygon is 3060. Classify the polygon by the number of sides. So this is essentially working backwards. We know that when we want to figure out how many sides does it have. So we know that when we take the number of sides and we subtract 2 from it to get the number of triangles, and then we take that times 180, we got an answer of 3060. And so this is giving you the answer and you need to work backwards. So we're going to set it up like this, and then we're going to want to solve for n because we're looking for the number of sides that it has. Sorry, I'm struggling to talk. All right, so we want to get rid of this times by 180 here first. You could distribute that if you wanted to first and then solve it that way. But if you just divide both sides by the 180 to start with, that will cancel that 180. And then 3060 divided by 180. I'm going to have to use my calculator for that one. My mental math is strong, but maybe not that strong. All right, so we got 17. So then you get n minus 2 is equal to 17. And then finish solving for n by adding 2 to both sides. And we're going to get n equals 19. And so this is going to be called a 19-gon. And you can always double check that by plugging it back in. If it has 19 sides, that means it has 17 triangles, and 17 times 180. 17 times 180 should be that 3060 degrees. So we can double check our answer working backwards. You could have also distributed the 180 and got 180 n minus 360 equals 3060 and then solved for n by adding 360 and dividing by 18, and you would have got the n equals 19 too. So a couple different ways to solve that equation. But the goal is to set it up by working backwards first. An interior angle of a regular polygon is 135 degrees. What is the interior angle sum of that polygon? So this is working backwards again too. So remember that when we are looking for the interior angle of a regular polygon, that is when we did this. We found each interior angle of a regular hexagon. We found the total number of degrees by finding the number of triangles times 180, and then we divided it by the number of sides that it had. So we need to work backwards. So we have the answer now, and so we need to figure out how to go backwards. So let's walk through what we did again. We want to know again how many sides does it have. So we take the number of sides minus 2, that tells me how many triangles it has, times 180, that gives me the total number of degrees that are in the regular polygon. And since it's regular, we're going to divide that by the number of sides or angles that it has. That's going to give me each angle. And in this case, we know that each angle is 135 degrees. So that's how we are going to set up this equation, and now we need to work through solving it. So we need to remember that the fraction bar represents division. So when we are solving an equation with a fraction, we need to use multiplication to undo the division. So we are dividing the left side here by n. To undo that, we're going to have to times both sides by n. So the times by n will simplify the divide by n, and we will be left with the n minus 2 times 180 equal to 135n. Now in this one, if I was to jump to dividing by 180 again to get rid of this, I'm going to be left with a fractional n over here. So to avoid the fractional n piece, I am going to distribute first this time. So I'm going to multiply both inside the parentheses by the 180. So 180 times n is going to give you 180n. 180 times negative 2 is going to be negative 360. And then that is equal to 135n. So now I'm left with an algebraic equation with variables on both sides. And so in this case, you want to get all your variable terms on the same side. So you're going to have to subtract the 180n since you have n's on the left and right. And so that's going to leave you with the negative 360. And then let's see, we're going to have negative 45n over here. And then you're going to want to divide by negative 45. And I know that 45 times 2 is 90. And then 90 times 2 is 180. And there's two 180s in 360. So that means that 45 goes into 360 a total of 8 times. And a negative divided by a negative is positive. So that means that there are 8 sides to this shape, which means that n equals 8 is an octagon. And in an octagon, it wants to know what the interior angle sum of that polygon was. So now we need to go back and just do this first step. So in an octagon, it has 8 sides. That means that there are 6 triangles, and 6 triangles at 180 degrees each would be, let's see, 6 times 100 would be 600. 6 times 80 would be 480, so 1080 degrees in an octagon altogether. So that would be the interior angle sum, and that's what we were trying to find in the end. So interior angle sum is 1080 degrees. All right. We are looking for the measure of angle B. And so first you need to count the number of sides or count the number of angles. So you got 1, 2, 3, 4, 5, 6, 7 sides. So 1, 2, 3, 4, 5, 6, 7. Or you can count the number of angles, which should be the same. 2, 3, 4, 5, 6, 7. So there are 7 sides and angles, which means, I'm going to just block this off because that goes to the other problem. Sorry about that. 7 sides and 7 angles, which means that it is called a heptagon. And hopefully I spelled that right. Oh, there's an A. Heptagon. We know that my spelling's not the best. Sorry about that. Okay. And then we see that angle B, D, E, and G are marked with that congruent mark. So those are all the same. Let's call those X. And so we are going to have a total of 4 angles that are the same thing. So we got 4 X's. And then we have 100 degrees, 160 degrees, and 140 degrees. And now we need to figure out what the total is equal to. Remember, to figure out the total, we need to take the number of triangles that are made inside this shape. So if there's 7 sides, 7 minus 2 is going to be 5 triangles times 180 degrees. That means that the total sum of these angles is going to equal, let's see, 500, and then 5 times 80 is 400. It's going to equal a total of 900 degrees altogether. So let's simplify the left side now. We're going to have 4x plus, we got 160 and 140 would be 300, and 100 more would be 400, equals 900 total. Then we're going to finish solving for x. So we're going to subtract off the 400 that we know is accounted for with angles A, F, and C. So that means we have 4 equal angles with 500 total degrees left over. And we want those to all be the same. So we're going to divide it into 4 equal pieces. And when you're dividing by 4, cut it in half, which would be 250. And then cut it in half again, which would be 125. So that means that each of those angles would be 125 degrees. So our question asked us to find the measure of angle B. So the measure of angle B would be 125 degrees. All right, one more for part 1 here. We're going to do another example with finding the interior angles using this shape. So you want to count the number of sides or angles again. So we have 1, 2, 3, 4, 5 sides, or 1, 2, 3, 4, 5 angles. So we got 5 sides, 5 angles, which would be called a pentagon. And then we know that the interior angle sum is found by taking the number of sides minus 2 to find the number of triangles that fit into this shape. So that would be 3. And then each triangle is worth 180 degrees. So that means that the angles inside this pentagon are going to add up to 180 times 3, which is going to be 540 degrees. Then we can make an equation by adding all of these angles together and setting it equal to 540. So we're going to have 2x plus 142 plus 2x plus 3x plus 14 plus 3x plus 14 equals 540. Now we have a couple of angles that are the same, so if you want to save yourself a little bit of writing, you could do 2x's plus 3x plus 14s plus 142 equals 540. If you do it this way, you will have to distribute. So you got 4x's and then 6x's plus 28 plus 142. Now combine your x's. So even if you started out with writing it all out, you should get a total of 10 x's, and then combine your constants. 42 and 28 is going to be 70, so 170. Then get your x's by themselves, so subtract 170. Going to end up with 10x equals 370. 540 minus 170. Just double check my math there. Yes. And then divide by 10. And dividing by 10 with something that ends in a 0 is easy because you just take the 0 off, and then 37 divided by 1 is 37. So x equals 37 in this question. And then remember that it also wanted us to find the measure of angle L. So to do that, we're going to have to plug it back in up here. So L was 3 times x, and if x is 37, and then plus 14. So 3 times 37, let's see, 3 times 30 is 90, 3 times 7 is 21, 90, 100, 111, plus 14 is going to be 125. So the measure of angle L is going to be 125 degrees. All right, we made it through part 1. So we're going to focus on the interior angle sum today. So the number of sides minus 2 times 180 is going to give you that interior angle sum. And then remember to work backwards if you need to, given the interior angle sum. Remember that the word regular means that all the sides and angles are the same. So all the angles are the same. That's what we're focusing on this lesson. All right. Thanks for watching.